obvious things. For example, using the icon view or the terminal view in an inconsistent manner. So maybe some VIs, or one developer in your team uses the icon view, another developer uses the terminal view. It looks inconsistent. If you deliver that code to a customer, they're probably going to notice that. It looks inconsistent. Class accessor names. This is a favorite of mine. So people create their LabVIEW classes with really long names, like National Instruments, DMM, and various part numbers after it. Then when you create a property node for that class, it's 7 inches long, and you need one of those widescreen monitors to even be able to see it. So you could actually go ahead and programmatically check for the length of your class names and do something about it by renaming them. Labeling wires. Maybe if you've got a long wire running across a LabVIEW block diagram, you want to check that you've actually used a wire label, because yeah, you've got a busy block diagram, it might not be immediately obvious what data that wire is actually carrying. And then front panel layout. This is one of the tests to ensure that the front panel matches the connector pane. It's good programming practice to lay out your front panel in the same orientation, controls on the left, indicators on the right, as your connector pane. It won't make your VI run any faster, make the CPU usage any less, but it's a good programming practice. It leads to consistency, and it's just a good thing to do. So, potentially dangerous constructs. Okay, so this is going to be quiz time. Let's see, which one shall we? Oh, I know which one we're going to pick. Okay, so we've got 6, 7 fairly innocuous-looking pieces of code there, but each one of them, if used incorrectly, could lead to a programming bug or unexpected behavior with your software. So for example, current VI path, it returns the path to the current VI. It's great, it's really useful, except it behaves differently between source and built applications. So the path that it returns might not be the path that you expect when you've built your application into an executable. So it's potentially dangerous. Instead, I would use application directory as an alternative. So it works. You're not going to see a bug immediately while you're working with your LabVIEW source, but you might see a bug when you build your executable. So it's what I would call a dangerous construct. The file dialog express VI. Anybody know what's wrong with that or why that might cause issues?
It's an express VI?
That wasn't what I'm thinking of, but yes. Absolutely. So the express VI is really interesting in that if the user cancels that dialog, not only does it throw an error, is it error 43? Mm-hmm. Error 43 it throws, but it returns a boolean to say that it was cancelled. So which one are you going to handle? Are you going to handle the error, or are you going to use the cancelled boolean output? So whilst it does work, it might give you unexpected behavior depending on how you've coded for a user cancellation downstream. So it has that potential to cause danger. So VI Analyzer is something that you could use to actually test for that, to say, have I used both of those outputs, and how am I using them downstream? We'll see how to do that a little bit later on. So that's right delimited spreadsheet. Anyone using that? That's good. So, right delimited spreadsheet, it has the ability to provide a runtime pop-up if no path is provided. Who's ever written a piece of software that's popped up a dialog and that piece of code's inside a loop and it's constantly popping up the dialog and it's task manager, Control-Alt-Delete, kill the process? If I run that piece of code inside a loop and I don't provide a path, I'm going to get hit with that dialog box popping up. So it has the potential to be dangerous. Okay, it's prize time. Who wants a pristine LabVIEW mode? Who can tell me what's wrong? It's probably a little bit small. Okay, so there we've got the pre-launch init VI of some actor, and in that code I've called launch actor core. Anyone? Nobody?
Me.
Hasn't it? Oh well. Here's what you could have won. Go on, then. One of these smart asses in the front. Go on. That's right, yeah. Nested actor. So, launch root actor inside the pre-launch init. Unfortunately, launch actor waits for pre-launch init to actually finish before it launches the actor. So that code, if you've got that code somewhere, when it gets to that code, it will just happen. Yeah. But you've got a run arrow. LabVIEW thinks that compiles just fine. The rest of your code might operate correctly. There might be certain scenarios where you only see that in certain execution paths in your software. So it's one to be aware. You can collect this later from the front. So a lot of people that I've spoke to actually this week so far have talked about how their LabVIEW software communicates with databases. They store their results in a SQL database. And I've often wondered, how people do that. And this is an example of some code that I've seen recently, where we've got an actual SQL command on the LabVIEW block diagram, and they've used format into string to pass the parameters into that SQL statement. Now, the diagram's a little bit small, but basically, I don't know what sanitation, is that the word? What sanitation is going on that input string prior to it hitting that function. But it's a common source of errors is to have strings being passed directly into a SQL statement. Okay? There really needs to be some kind of precondition checking of that input prior to it being passed into the string. Passed into the format into string, should I say. So unsanitized inputs into SQL statements could be bad, because it depends what's on the string. If the string's got a valid input, the SQL statement's going to run just fine. If it's empty, it might not run at all, or we might get unexpected behavior on the database side. We've got a case structure with a string, in one of the cases, being passed out, and I wish I had a laser pointer. You can see on the right-hand terminal, we've got the little white dot. Does anybody know what that means? That's right, use default if unwired. So if I don't wire every case, LabVIEW will look at the default for that particular data type. Oh, spectacular. Thank you. Can avoid blinding anyone. Oh, look at that. There we go. There. So the little white dot that's on the terminal, that signifies that that case structure is set to use default if unwired. In the case of a string, an empty string. What's wrong with that? Well, it depends what's downstream. It depends if the downstream code can handle an empty string being passed to it. So, whilst that compiles just fine, it could be dangerous depending on what code comes after it. And then finally, and this one's one of my favourites. So we've got a loop boundary, and we've got an array that's indexed. And then in this case, we've got a I/O reference, a Visa reference to maybe a USB or GPIB instrument or some kind of instrument. So we've got an indexed array. Maybe that's carrying some information like voltage or frequency, and we're wanting to iterate. So this loop is iterating over whatever is that numeric array. Anybody see any potentials for danger here? Absolutely, yeah. So, as our friend just said, there's an empty array, the loop doesn't run, but unfortunately we lose whatever referendum was on the wire. Question?
No, I was just going to say, in the past 30 days, I had that exact problem come up with some code in that I inherited.
Yep.
And what was wild is you had this loop that would execute 0 times, and then the next icon after that was something to close the reference. And then the next icon after that was clear all errors.
Yeah. I think the expression for that is technical debt. So, empty referendum if the array is empty. So these are the things that we want to test for. So Okay, you're all sold. There's potential danger in our LabVIEW code, stylistic, performance, dangerous constructs. You're all sold. So why don't developers use VI Analyzer? Actually, let's just do a quick show of hands. Who's using VI Analyzer regularly as part of their workflow? Okay, maybe 20%, something like that. So why don't people use it? Well, these are some of the things I hear about. Well, I do acceptance testing anyway, so I'm going to test the thing with a big system. I'm testing my nuclear warhead. I'm going to plug it into the big test system. If there's a problem, I'll find out about it. My customer doesn't pay for style. That's what I hear quite a lot as well. They're not paying for well laid out code. They just want it to work. It fails for things I don't care about. That's a common one. Or it's disruptive to the way I work. There are just so many results to trawl through. So if we look at those, and those are all things I've genuinely heard, we look at those, we can categorize them as noise. It gives a lot of results. There's a lot of information there. What we might call false positives. It's failed for something, but do we really care about the thing that it failed for? And then workflow. It's disruptive to the way I work. And if we think back to the slide where I showed how it runs in the video, I have to, in my VI, go to the Tools menu, select the VIs that I want to test or analyze on the project, and then go through that configuration. It is somewhat disruptive. So I think those are the reasons why people don't use it. Noise, false positives, and workflow. So if I can give you a solution to those three problems, when I ask the question again next year, who's using VI Analyzer, I won't have a presentation to give. We can sit and drink beer at that point. So we can do what's called creating a configuration. This is going to help us reduce the false positives, reduce the noise. We'll talk about the workflow a little bit later, but let's reduce the noise and the false positives by selecting what should be analyzed and how it should be analyzed. So we're selecting which tests are important to us and how those tests are going to be performed. So we can create configurations of tests, lists of tests that run. And I propose that you create different CFGs for different scenarios. So for example, if you're providing demo code to a customer that they're going to use as an evaluation board, you probably want to run a lot of tests on that because you're going to have a really bad customer experience if they run your example code and it falls over straight away or it's got a bad layout. They see wires running under objects, they're going to be like, this guy is just haphazard and maybe this reflects the rest of his project. There are certain tests that we want to do every day. There are certain constructs that I get wrong or that I just mentally switch off and forget to check for. They're the important ones. Yeah? Testing for wires, if I see a wire behind a block diagram, that's because I've just been lazy. I'm not overly concerned about that. It's the ones that I know I always miss. They're the ones that I really want to be checking every day. Pre-delivery inspection. You know, if we're shipping a system out to a customer, we probably want to run everything. High performance applications, we probably want to concentrate on things like memory usage, loop iterations, hammering the CPU and railing that. We want to make sure that the application and the code behind it is as performant as possible. Cross-platform portability. So if you have to support your application on multiple platforms, maybe your application runs on OS X or Linux, you might want to run some tests to check that you've not used ActiveX, for example, which is only going to work on Windows. Or that paths translate correctly between platforms. So you might want to have a specific test suite, a specific configuration that runs and checks for cross-platform portability. So let's have a look at creating and saving a VI Analyzer configuration. Okay, so I've got my two VIs again, my block diagram with issues and my front panel with issues. I go to VI Analyzer, so the Tools menu, VI Analyzer, Analyze VIs. I can now select which VIs I want to analyze, or select a project to be analysed. In this case, I'm going to select the project that contains those two VIs. So there they are listed. And I'm going to pick which tests I care about. In this case, I care about non-transparent front panel labels, and I care about wires under objects for this example. So I select those tests, and once I'm happy with that configuration, and you can see there's something like 97 pre-written tests, maybe it's over 100 now, I don't know. But there's approaching 100 inbuilt tests that are provided by NI to test your code. So you can go through that list and select which ones are important for you, and then you can save that configuration. Okay, so I'm hitting save, I'm going to go and put it somewhere. Let's call it NIWeek demo or something, and let's save that configuration. We can choose to password protect it. Maybe you want to provide a configuration to your team and say your code must pass all of these tests, password protect it, so they can't deselect them all and go. So there's my non-transparent label test. It failed, and it asked me, do you want to see the result? Do I want to return to the VI Analyzer? No. Go back to my project, and now I can go into VI Analyzer, analyze VIs, and this time I don't have to do all that tedious ticking of boxes and selecting of files. I can just say, let's load an existing configuration, and there it is. My VIs have been selected, the test that I want to perform has been pre-selected. I just hit the Analyze button, and I get the result. So that's helping a little bit with that workflow problem. That's helping a little bit with the noise problem that I talked about, because we're only running the tests that we care about at that specific point in time. So there's our results, and we've still failed for the same things. We'll go and fix that in a minute. So that's our VI Analyzer configuration. Who thinks that configurations might tempt them to use it? Oh, I've only saw, another 20%. We're getting there. We can get another 20% by the end of this presentation. I'll be happy.
Question.
Yeah, question.
Is the configuration always linked with the source files?
So, the config...
Yours was.
Yes.
That wouldn't work in giving it to your team.
That's right. So, the configuration from an interactive, using the dialog box point of view, is linked to the source files. Yes. We'll see in a little while, using there's an API, we'll talk about that some more, but we can actually take that configuration and pass in a different list of VIs to analyze, but performing the same tests. Yeah. So, style guidelines. Everybody's department got one of these? Everybody's... Oh, okay, so style guidelines. Who uses the one from NI that was written in 2004? Things have changed. We've moved on a little bit from them. So what I strongly suggest is that you and your team sit down and you actually think about how you want to lay out your LabVIEW code. What constructs are you going to outlaw as a team, banish? What things are you happy with? Things like separating source code from compile code. So you're using source code control, and you've got one guy on your team who doesn't have that option ticked. So every time he changes one VI, that change propagates through his whole hierarchy, and you see 50 VIs have changed in source code control. Right? That's not helpful. So a style guide doesn't only include how you write your code, but also how you have your LabVIEW environment configured. So this is your opportunity to define your own rules, and then use VI Analyzer to enforce those rules, to check that everybody's following them. So you can define your own rules for things like file names, LabVIEW options, like that particular one. You can define rules for your block diagram, things like let's not use current VI's path, let's use the application directory VI. Let's not use file dialog with both outputs wide, let's just always use the cancelled boolean, for example. Or let's check for error 43. Yeah? But decide as a team how you're going to do this thing. Put it in a Word document with a few screenshots. That's your style guide. It's useful to get alignment of style within teams. You know, what happens when Bob goes on holiday for 2 weeks and nobody understands how he wrote his code, yeah? And we have to wait for him to come back? Enforcement of style helps with those situations if you can get everybody coding in the same way. And then you can use VI Analyzer to police that. to check that everybody's following that guide. Okay, so I suggest a good thing to do this year, ready for NIWeek 2020, go and sit down with your team, get buy-in, and write a style guide. And then you can apply your own rules by building your own VI Analyzer tests. Yeah, so we've got 96 tests that ship with VI Analyzer, but you can build your own as well. So VI Analyzer includes a tool called the Test Creator. It takes a template for a VI Analyzer test, asks you what you want to call it, and then you add the code that's going to perform that test. The code that you add uses VI server properties and methods to analyze the block diagram of the VI that you're analyzing. Okay, so you're looking at wires, objects, structures, and checking it to make sure it complies with the rules that you defined in that document that you wrote. And then you put your tests in this directory, and they magically appear in VI Analyzer. You can tick them in future. They're available to you to save in configuration. So if you put your tests in this directory, they become available for you and the rest of your team. You can tell them all, put it in there, or use some sort of package management to do that, and they can run those tests as well. So I've got a noddy example. This is not a real example, but to try and keep the block diagram a little bit simple, in this case, I've decided that I don't want to have unused array indicators on my front panel. If it's not wired to the connector pane, I don't want it there. This VI is not a user-facing VI, therefore having an unwired array indicator on the front panel is potentially a resource issue, especially if it's just a duplicate array. Why have that? It might be creating a data copy. Who knows? So I've decided that that's my rule. I'm not going to allow that. So here I've actually written some VI server code that's actually looking for that particular construct in any VI that it tests. So any VI it tests, it says, okay, is there an indicator? Is it an array? Is it on the connector pane? If it fails that condition, then it needs to be that code needs to be repaired, or it just needs to fail the test. So that's the code that I've written to look for that particular construct or that particular thing that I don't want to have in my code. Okay? So unused array indicator is the thing I'm testing for. That's the message there, and that's the code to actually test for that. And it's all standard LabVIEW code. It's VI scripting, VI server to analyze for that. So another example that might be testing for non-transparent control labels. So again, I might take my panel reference, get all of the controls on the panel, and see if any of them have a label background color that is not equal to transparent. If it's not equal to transparent, then it's a failure. So I'm rolling my own tests. I'm going looking for the things that I care about, not the 96 that are in the list from NI, but the ones that I care about. If you don't want to write your own, or before you write your own, I strongly suggest you look at the VI Analyzer enthusiast group on ni.com. I've not counted, but there are, you certainly have to scroll down the page to see them all. There are lots of tests that other people have written to test for various things, various dangerous constructs. For example, clusters or enums that are not type defs, things like that. Things that have the potential to disrupt your workflow or to cause issues with your software. So check out that as a good starting point, get some inspiration. VI Analyzer enthusiast group over on ni.com. So you could also choose to ignore code. So let's say that you've got a particular piece of code that you know doesn't comply with one of the rules, but you don't want that error popping up, you don't want it appearing in the report that you ship to your customer. You could choose to ignore it. There's a couple of different mechanisms. The easiest one is to use LabVIEW 2018, because in LabVIEW 2018, they introduced a feature to allow you to selectively ignore tests for particular VIs, or have certain VIs not be tested 100%. So you could upgrade to, oh, that's a terrible low resolution. So upgrade to 2018, and that will allow you to ignore some tests. Or you could just write your own code in each of your tests. In this case, I said, okay, I'm going to create a LabVIEW bookmark called VI Analyzer skip. And there's a VI that ships with LabVIEW that's used by the bookmark manager that returns all of the bookmarks. So I just look in that list and say, am I skipping it, yes or no? If I am, I ignore it. Okay. So selectively skipping tests if it's not important, or if you know you're acknowledging. I like the bookmark way because it's taking an acknowledgement from you, okay? I need to put a bookmark in order to ignore this test. It requires some interaction with the developer. Okay, so that's a good thing. It's a check that, yep, I'm going to ignore this, but I need to create a bookmark in order to do so. So you could choose to ignore some code. So VI scripting, anything that you can do with VI scripting could be incorporated into a VI analyzer test. Absolutely anything. VI scripting allows you to obtain a reference to the block diagram, to create objects, to move objects, to wire things together. It allows the removal of items. So what does that mean? Well, it means that we could potentially write code to fix some of the issues that we find as well. So if we've got some code, and again, it depends on your environment. If you're in a mil-aero environment, this might not be appropriate, but you might want to actually allow certain constructs to be fixed. So let's see an example where that might happen. Well, let's go back to our redundant indicators on the connector. So we've only wired one of them to the connector pane. So I know that if that one wasn't there, it's not going to affect downstream code, unless I've got something crazy going on with control references on the output. So I've actually written some code here that if it fails the test, if it finds that duplicate array indicator, I don't delete it because that loses a little bit of traceability. So what I do is I programmatically put that piece of that array indicator inside the diagram disable structure. So it's compiled out, but it's still there on the block diagram for reference. Again, I say it's an example just to try and give you a simple block diagram. But if it finds that, a duplicate array indicator, it puts it inside the diagram disable structure and then programmatically adds a bookmark to my block diagram to tell me VI Analyzer repaired an unused array indicator because it failed the test. So I've got that traceability, but I've gone ahead and fixed it programmatically. So VI Analyzer not only can analyze the code, but it could actually take action in certain situations. So for example, if I got one developer who worked for me and he used non-transparent control indicators in every one of his VIs, and I say, oh, I don't like that, to actually give somebody the task of fixing that might take some time. If I add the code in my VI Analyzer test to change them back to transparent programmatically, then I just run the test, it fails, and it updates all of my code. So you've got the ability to modify and fix issues. Any questions on the modification? Yeah?
How do you get to that test creator?
Okay, test creator. It's in the VI Analyzer menu. So Tools, VI Analyzer, Create New Test.
Oh,
okay. So there's an API as well. Yeah. So not only do we have to go to the Tools menu and say, yeah, I want to load a configuration or I want to select the test, there's an API. So we can start to build VI Analyzer into our workflow, build it into the tools that we've already got. So let's see an example of that. So let's start playing with the VI Analyzer API. So in this example, I've got my two VIs with their block diagram issues and their front panel issues. And in this case, I don't like the workflow. I didn't like having to go to the tools menu. So let me just rewind that again. I was told. So what I've actually done is create a project provider so that I've got a right-click option to just be able to spontaneously run a VI Analyzer test on a particular VI. So I've got a VI, I just want to test it and see if it passes without having to go through the whole process. So I've got a VI Analyzer project provider that allows me to either run a selected configuration and then store that configuration in a recent list. So there we go. So I'm going to run a specific configuration. I'm going to run my NIWeek demo that we created in the earlier example. And that's it. It's run. It's going to fail. hopefully going to fail. Yep, it failed. I can double click on it and it takes me to the failure. But also notice, it's finished, and then we go back to the project. I've also put a little red dot over the VI in the project now to indicate that there's a VI analyzer failure for that particular VI. So I can look at my project and say, yeah, I know there's code in that I need to go and fix. Now, unfortunately, I'm lazy. I'm not going to fix it, so I'm going to add a bookmark to skip that code in future. So I could do a bookmark using a text label, but I've also created a little tool that allows me to add bookmarks to multiple VIs from the project window. So I type my bookmark in, I've got some pre-written ones down here. The one I care about is VI analyzer skip. So it's still got the code in, but it's now got this bookmark that's been added to the block diagram telling VI analyzer to skip this VI. I'm going to go ahead and close it. Let's run it again. So I'm going to go VI analyzer. My NIWeek config is now in my recent files list, and it now skips. I had a good suggestion from somebody this morning to change that to orange to indicate it had skipped rather than green, because that suggests it passed. But that's all done using the API. So you can see that being able to just right-click on a VI is far more easy than going to the tools menu and selecting a config and interacting with those dialogues. It fits my workflow a lot better. Because it has an open API, you can integrate it into however you work. So let's take that a step further. Let's think, well, we're all using source code control. Let's start checking the code before we commit it to the repository. That Joel guy again, he's got a passage in the book that says, in general, the longer you wait before fixing a bug, the costlier in time and money it is to fix. I'd go one further. A lot of people, once they've committed code that's got a fault in it, it stays committed, it stays faulty. Yeah. It's much quicker and easier to fix the fault when you find it. The sooner you find it, the better. So if you could actually make VI Analyzer run every time you commit into the repository, maybe not that whole suite of tests, but 2 or 3, 5 key tests, things that you really don't want going into the repository, you don't want being made available to the rest of the team who are using source code control, then we can use VI Analyzer to do that. So I'm not going to go into too much detail. I'll be giving a presentation later in the week, a step-by-step guide on how to implement this. But what we use is something called a pre-commit hook that allows us to run a series of actions when we commit code to source code. And one of the things that I do is I say, okay, when I'm committing, let me get a list of all the files that have changed. What's changed? Because I only care about stuff that's changed. Let's get that list and let's run the VI Analyzer using its API. Okay? So I'm committing source code to my repository. I want to look at which VIs have changed, and then let's go ahead and analyze them. Okay? And it's just using the API. I've written minimal code to actually support that. So let's go ahead and see that in action. So this is my source code control tool. I use Tower app for Git. So I'm going to go ahead and make a change to a VI. So here's my VI. I'm going to go ahead and make a change to it. So in this case, literally, I'm just going to move something on the front panel, but it forces a resave. Now when I go back to my back to my source code control tool, I should see that one file has changed. Yeah. So I'm seeing one file has changed. I'm going to go ahead and add a message that details what commit I'm making. I hit the commit button, and behind the scenes now I've triggered VI Analyzer to go and look at that one VI and run those tests that I've selected on that VI, and it should fail. I think it's got a wire behind it. Yeah. Okay, so it's got the duplicate array indicators. But what my VI Analyzer test did do, I saw briefly there, if I just jump back, what my VI Analyzer test did do is it fixed the problem and it added a comment to the block diagram telling me that it had fixed it. Question?
In this case, you didn't stop the commit, right?
I did stop the commit. Yeah, so I hit the commit button, I've got one VI has changed, it's unstaged, I hit the commit button, Sorry, I went back a bit too far. I hit the commit button, it fails the test, it stays uncommitted. Yep. So I'm not allowed that code into my repository until I've got... Now, in this case, VI Analyzer fixed the problem for me. Yeah. So VI Analyzer fixed the problem for me, but it's still not been committed. Now, I commit it with a new message, and it's been allowed in. Because VI Analyzer fixed it, that code's now acceptable. I can now put that into my source code control repository. I'm a little bit shy on time, so I'm not going to go into the server side of things. So, in summary, reviewing code increases quality. We're looking at performance, that's code quality, how performant our code is. We're looking for bugs, that might be style, dangerous constructs. So VI Analyzer can perform your code review. So all the people that were in the room who were thinking, I don't do code reviews, I'm a one-man band, well, you've got somebody who can do the code review for you. VI Analyzer can modify your code, it can fix things, it can save you time if there's something that you're happy with VI Analyzer fixing. But it's got an API, so it can be integrated better into your workflow. So instead of having to go to the tools menu, I wrote the little project provider to be able to do it on a right click. Honestly, it wasn't a huge amount of work to do that, and it's a lot easier now being able to just right click. Please write a style guide now. So finally, further reading. If you're interested in what you've seen and you want to get started, hopefully that's the 60 or 70% of people that aren't using it right now. Have a look at improving code quality through automated code analysis. This slide will be available after NIWeek. If you want to take a card or talk to me afterwards, I can make it available to you more quickly. Have a look at VI Analyzer Enthusiasts community page and the blog that's run by Darren Nattinger. There's some really good community tests on there to save yourself a lot of time. If you're free later this week, I've got a couple more presentations I'm going to be giving. So I'm going to be talking about integrating LabVIEW with Jira tomorrow, 2:30. I'm going to be talking about continuous integration. So when you make changes to your code and you hit the commit, you want to see your executable built, tested. I'm going to be talking about that on Thursday, and how to build a better, faster, stronger LabVIEW team, but not looking at the technical aspects of it, again on Thursday. So if you weren't put off by this presentation, feel free to join me later on in the week. So with that said, questions? Oh. They were custom. Yeah, they were custom. That's quite a bit of scripting. Yes. The VI Analyzer community ones are the ones that the tools that I built. Yes, the tools that I built. If you like those tools, come and talk to me, or put your hand up and say, Chris, please put those on GitHub and make them available to everybody. No, seriously, I do have meetings with the LabVIEW Tools Network team. I would like to make those available if there's interest in me doing so. Let me know that you like them and I'll do my best. But any questions, you can get hold of me there or take one of my cards and I'll be happy to answer any questions as well. Anyone else? Okay, thank you very much.